Ever wondered how Bitcoin transactions are secured? The answer lies in the ingenious technology known as blockchain. Blockchain is a decentralized and distributed ledger system that ensures secure and transparent record-keeping without the need for a central authority. Think of it as a public ledger that everyone can see but no one can alter easily. Each participant, or node in the network has a copy of the entire blockchain, and no single entity has control over the entire system. This technology serves as the backbone of cryptocurrencies like Bitcoin and Ethereum, but it doesn't stop there. Blockchain's applications extend far beyond digital currencies, reaching into sectors like supply chain management, healthcare, and finance. Its decentralized nature, combined with its robust security, makes it an attractive solution for scenarios where trust, transparency, and immutability are crucial. Let's delve deeper into the key characteristics of blockchain technology, starting with decentralization. Decentralization is one of the most critical aspects of blockchain technology. It forms the backbone of the system, setting it apart from traditional centralized structures. But what exactly is decentralization, and why is it so important? Well, let's start with an analogy. Consider a library where all books are kept in one place, under the watchful eye of a librarian. The librarian decides which books are added or removed, and keeps track of all the books checked out by readers. This is what we call a centralized system. If this library was to catch fire, all the books would be lost, and the knowledge within them gone. Now, imagine a different kind of library, a decentralized one, where every reader has a copy of every book. If a new book is added, every reader gets a copy of that book. If one reader's books are destroyed, the knowledge isn't lost because all the other readers still have their copies. This is how decentralization works in the blockchain. Each participant or node in the blockchain network has a copy of the entire blockchain. Every transaction, every block is recorded on every node, making the system incredibly resilient. There is no central authority or single point of failure. If one node goes down, the system carries on. This decentralization also means that no single entity has control over the entire system. Transactions are verified by the collective network, not a central authority. This peer-to-peer network creates a level of transparency and security that is not achievable in centralized systems. Decentralization is what allows blockchain technology to provide a secure and transparent record of transactions. It is the key to the trustless environment where parties don't need to know or trust each other to interact confidently. Decentralization isn't just about robustness and security, though. It's about democratizing access to information and removing the need for intermediaries. It's about creating a system where power is distributed, not concentrated. So, there you have it. The essence of decentralization in blockchain technology. It's not just a feature, it's a fundamental principle that underpins the entire system. Now let's move on to another fundamental characteristic of blockchain, the distributed ledger. The distributed ledger technology is what makes blockchain so unique and secure. Now let's delve a little deeper into the nuts and bolts of this technology. Picture a chain, where each link is a block. Each of these blocks contains a list of transactions. When a new transaction occurs, it is verified and then added to a new block. This block is then connected to the chain, creating a chronological and public record of transactions. This chain of blocks is known as the blockchain. But what makes it distributed? Well, this is where the magic happens. Instead of being stored in one central location, this blockchain is replicated across every participant or node in the network. Each node has a complete copy of the entire blockchain. This means that the data isn't just stored in one place, it's distributed across the entire network. This distribution has some pretty significant benefits. Firstly, it enhances security. Because the ledger is replicated across all nodes, it's extremely difficult for a malicious actor to alter the data. They would need to change the information on more than half of the nodes simultaneously, which is virtually impossible given the scale of most blockchain networks. Secondly, it ensures the information is resistant to tampering. Once a block is added to the chain, changing it would mean altering every subsequent block in the chain across every single node. Imagine trying to change one link in a chain while keeping the rest intact. It's not an easy task, right? This distributed ledger technology also brings a new level of transparency. Because every transaction is recorded publicly and cannot be altered, it creates a system where everyone can trust the information on the blockchain. This is particularly crucial in financial systems where trust is paramount. In a nutshell, the distributed ledger is a revolutionary technology that's at the heart of blockchain. It's what gives blockchain its security, transparency, and resistance to tampering. The next crucial aspect of blockchain we're going to discuss is its immutability. Immutability and consensus mechanism are two pillars that ensure the integrity of blockchain transactions. Let's start with immutability. This principle states that once a block is added to the blockchain, it's incredibly challenging to change or remove. Think of it like a digital cement. Once it hardens, it's there to stay. This immutability is achieved through cryptographic hashing. Each block in the chain contains a unique code called a hash, and any attempt to alter the data within the block changes this hash. But here's the clincher. Each block also contains the hash of the previous block, creating a kind of digital DNA. So altering one block would require changing all subsequent blocks, a task nearly impossible given the decentralized and distributed nature of blockchain. Now, let's move on to the consensus mechanism, the democratic heart of the blockchain. When a new block is to be added to the chain, there needs to be agreement among the network participants. This is where the consensus mechanism comes in. It's a set of rules that all nodes in the network follow to agree on the validity of transactions and the order of blocks. Several consensus algorithms exist, each with its strengths and weaknesses. For instance, Bitcoin uses the proof of work consensus algorithm. It requires participants to solve complex mathematical puzzles, a process that consumes a lot of computational power and energy. On the other hand, Ethereum 2.0 adopts the proof-of-stake consensus algorithm, where the creator of a new block is chosen deterministically based on their wealth or stake, making it more energy efficient. The immutability and consensus mechanism work hand in hand, creating a system that is secure, transparent, and democratic. Any attempt to tamper with the data would not only require a gargantuan amount of computing power, but also the consensus of over half the network's nodes. Another fascinating feature of blockchain is the concept of smart contracts. Blockchain is not just about cryptocurrencies, it's a technology with potential applications in many areas, one of them being smart contracts. So, what are smart contracts? Imagine a vending machine. You put in a coin, select your snack, and the machine automatically dispenses it. A smart contract works similarly, but in a digital context. Smart contracts are self-executing contracts with the terms of the agreement directly written into code. They live on the blockchain, making them decentralized and tamper-resistant. When predefined conditions within the contract are met, the contract executes itself. This could mean transferring funds, releasing documents, or any other programmed action. The beauty of smart contracts lies in their autonomy, accuracy, and speed. There's no need for intermediaries, reducing costs and potential errors. But the magic of blockchain doesn't stop at cryptocurrencies and smart contracts. This technology is stepping beyond the realms of digital currencies and finding applications in various sectors. Take supply chain management, for instance. The transparency of blockchain could provide a clear, unalterable record of a product's journey from manufacture to sale. It could help verify the authenticity of products, combat counterfeit goods, and enhance consumer trust. In healthcare, blockchain could securely store patient records, ensuring privacy and easy access for authorized persons. It could also track drugs to prevent counterfeiting, ensuring patient safety. In finance, blockchain could simplify and expedite transactions, especially cross-border ones. It could make the system more transparent and resistant to fraud. Even voting systems could benefit from blockchain. It could offer a secure, transparent, and tamper-proof platform for casting, tracking, and counting votes, potentially eliminating electoral fraud and enhancing trust in the democratic process. To sum up, blockchain is much more than a platform for cryptocurrencies. It's a revolutionary technology that could transform various sectors, improving efficiency, transparency, and security. It's a technology that's here to stay, and we're just scratching the surface of its potential applications. Blockchain is a transformative technology that promises to revolutionize many sectors of our economy. In summary, blockchain is a decentralized, distributed ledger technology with high security and transparency. Let's recap what we've covered. Blockchain's backbone is its decentralization, taking away the need for a central authority and instead empowering a peer-to-peer network where each participant has a copy of the entire blockchain. This results in a distributed ledger, a chain of blocks containing transactions that is replicated across all nodes in the network, enhancing security and making information tamper-resistant. The immutability of blockchain, where altering a block is highly challenging, is another key characteristic. This is achieved through cryptographic hashing and the network's consensus mechanism. And then we have smart contracts, programmable contracts that are self-executing and enforce agreements when predefined conditions are met. Beyond cryptocurrencies, the applications of blockchain technology are vast, spanning supply chain management, healthcare, finance, voting systems, and more, thanks to its trust, transparency, and immutability. As we continue to explore and innovate, blockchain technology's potential seems limitless. Stay tuned for more insights into the world of finance and technology.